Hey folks, welcome to the fourth and final session in our GH-200 Automating Your Workflow with GitHub Actions. I'm Rob Folkrod, a Microsoft technical trainer and longtime MCT in the developer and DevOps space. In this last section, we're going to be looking at the organization and enterprise level configurations. Our theory so far has been very much of we're looking kind of an individual repository. We haven't really gone much beyond that. But many of you may be aware that we group together repositories by way of either some sort of owner or some sort of organization. Right? So we've got the repository level, then above that, the organization level. As many of you are probably in larger organizations in which one organization is simply not enough. We need more subdivisions. And so as we divide, we also need something to group. And so above the organization level is the enterprise, made up or composed of many, many different organizations, which are then composed of individual repositories. So when it comes to actions, our focus, when it comes to actions, what knobs and switches and dials do we have at the organization level and at the enterprise level to configure or give policy over those actions? Right? So that's what we're going to be looking at. In here specifically, we're going to we'll quickly define a couple actually different enterprises, but we'll take a look at the different tools and the different policies that can be applied at the organization enterprise level. For actions in general, we will then take a look at the runner level, right? The runners being the tools that are actually executing the underlying actions. We'll take a look there. And then finally, we'll look at secrets. So in an earlier session, we saw secrets could be applied at the environment level or at the repo level. And now we'll start moving that up in scope. And so that's our quick and final collection. First, before we get into too much of the individual components, we do want to be kind of aware of what it means by enterprise. We've got a couple of different options. Option number one, GitHub Enterprise Cloud, GHEC. Enterprise Cloud is going to feel, in many respects, very much like the interface that you are accustomed to with GitHub. You're going to be accessing this by way of your browser through the github.com. But inside of github.com, there is an enterprise account built specifically for your enterprise, your tenant. Now, we also have GitHub Enterprise Server, GHES. Now, we're going to differ considerably here because this is going to be, in essence, an on-prem product. There are many organizations in which they really can't take their code and push that up to a cloud organization. It needs to remain on-prem. It needs to remain in-house. It may require that it has no internet connection whatsoever. You're going to need your own server. And that's GitHub Enterprise Server. You build your own on-prem version of GitHub. So when we are talking about enterprise, we could be talking about either one of those. In many cases, we'll be referring to both of them simultaneously. But if there are differences and when we say, well, this is specific to server, we will call those out. Both enterprises, whether it be in cloud or server, beneath them will have multiple organizations. So in my case, I am part of a worldwide learning organization. So kind of the training aspect, that's an organization that I'm a part of internally. But there are many, many others in the Microsoft realm that I have no affiliation with whatsoever. I'm in my own little org. And that's probably the case in many of your orgs as well, where you are part of one wing of the org and may have your own organization there. All right. So first thing we're looking at here with that definition out of the way is what are the configurations that we can apply at the enterprise and organization level when we're looking at actions and workflows. So first, we go to the enterprise level. And in the enterprise level, we have a section here where we can start applying individual policies. And in this case, we're saying, if I am building a workflow, that workflow is going to be composed, we know this now, is going to be composed of many actions. Are all actions appropriate for this particular org or set of orgs? Can anybody use any action? And in many cases, an enterprise is going to say no. Very much like my developers, are they allowed to use just any dependency? Can they just see an assembly out there, see a library out there, and just use it? Well, no. We don't necessarily trust anybody's code unless we've gone and validated that. Well, actions themselves are code. So we will need to have some sort of control over which individual actions are we able to use. And so at the enterprise level, we can go ahead and we can then specify, sure, yeah, maybe these orgs here can use all actions and reusable workflows. If you can find it, you can use it. Option number 2 says, if they are in our own enterprise, then you are able to use. Right? That any actions that we define internally, we can go ahead and supply. And then option number 3, we can go in and specify which ones are we able to use that are both in and out of our enterprise. So we can go in and query those all up. We can specify here which organizations, we can say there's a little filter in there where we can specify which organizations are these going to apply to. So for example, here, we're saying we're going to allow enterprise, non-enterprise, but we're also going to then have a list. Right? And we'll delve a little bit deeper into that one so you can see here. And so we're saying we're going to allow, in this case, and this is a little bit of an old screenshot, but checkout version 2 is going to be available to us. And Mona Lisa, Octocat, any version, you see the @ there at the end of that one. So any of those could be a possibility. So in that third option, you can create allow or deny lists. The bang operator will allow you to specify a section that can't be used. So here we can give individual control over which actions could be used. If you recall Enterprise Server, that this is an on-prem product. All of those actions, like action/checkout, is sitting on the GitHub website. That requires a call to an external component, or one would think. Well, what Enterprise Server does is those common actions are automatically downloaded onto the server itself. So you are free to continue to use checkout or upload artifact or download artifact. Those are already on the server. However, the update to that is going to be a little bit more periodic. It might be a little bit slower to get the latest updates for what are housed on github.com. So that's kind of the trade-off. When you isolate yourself, you end up a little bit isolated. What we do have as an option, though, here is what's called the Actions Sync tool. This is a tool that allows you or your administrators to selectively say, I need to grab perhaps maybe the more latest versions of certain actions and bring them down on-prem so that they can be run locally. So this is something that you're just going to see on the enterprise server level because it does have that isolation. At the same time we can set things at the enterprise level, we also have control at the individual organization level. And so it's in a slightly different location from what we saw before. It's in settings, actions, and then instead of a policy section, it'll go into general. But we have a similar set of controls here when it says what workflows are allowed to use which actions. And the default is, again, all actions, right? That if you can find it, you can get your hands on it. That is the default level. You may want to start to tighten that up a little bit. So we may say only the actions that are created by GitHub, so the ones that are in the actions / collection, right? That'll which can limit that down, or only the ones that are inside of your organization specifically. As your security gets more tight, you may want to say the ones that we have built, and you may duplicate, you may copy some of the common ones into your org so that they are available locally. Okay. Or tighten up completely and say, I will tell you specifically which ones you are allowed to use. And you can specify, again, that same idea of an allow list that we had before. So we may say, actions checkout and specify a particular version. Version 4 is allowed, but we can't use version 3 because of XYZ. Or any of the node options may be allowed. We can go in and we can set those policies, again, at the organization level. We can also take a look at specifying when a workflow executes, what is the workflow allowed to do? Can the workflow make any changes back into the GitHub repository? Can it commit something into the repository, right? Or is it allowed to run but not influence the repo itself? So we've got two options in there, right? The read only, which says the workflow can pull down, right? We can check out from the repository, but we can't push, we can't make any changes back up. That is recommended if we're in a higher security environment, or we do allow, right, the both read and write component. Right. So here again, settings, actions, into general is where you'll find those options. One additional configuration we can take a look at is when is a workflow allowed to execute? In earlier modules, we saw that there are triggers. Someone did a push or someone did a pull request, and it can automatically trigger that. The reality is it can be a little bit more complicated than that. So many of you, if not all of you, are aware that GitHub allows folks to, in many cases, to clone, to fork one of our repositories, where they can make changes to that repository, and then often submit a pull request for us to then get their changes. This is how the open source world works in many, many cases. Here's the thing, that actions and the workflows themselves are written in those repositories. That we don't necessarily know what they have done in those repositories, and the vast majority are probably perfectly safe, innocuous, helpful contributions from the outside world. And then there's the other ones that are not. And what we don't want to happen is someone to create a pull request that we don't know, that we don't trust, and have it run those actions, which are just code. So we don't want to give arbitrary code execution to just anybody. Long story to get to this particular slide here, but here inside of actions in general, you get to determine what happens with a forked pull request, right? Which is different than an internal pull request. If I am part of the team and I create a branch and I add new code and I then create a pull request, I'm part of the team, I'm probably trusted. I'm hopefully trusted. But a forked repository could come from anybody. So there is a different bar. So under that, we can go ahead and set some settings to require approval from workflows from running forks. This makes a tremendous amount of sense, that someone has to take a look at being able to say yay or nay, this should run, this shouldn't. There's also a, nope, it's fine, I trust the world, allow automatic execution of forked workflows. Probably shouldn't really be a thing. We'll talk more about kind of arbitrary code and execution coming up. So we also have to keep in mind the different types of runners that we have available to us. We have the GitHub hosted runners, and we have our self-hosted runners. Okay, now think to yourself real quickly, which of those am I more safe running someone else's code on? Right? If someone contributes, where am I more safe for that code to run? On a GitHub hosted server or on my own? I'm hoping you were saying to yourself, well, on a GitHub hosted server, I am more safe because that is isolated from everything in my org. But if it's self-hosted, then we have built a machine somewhere that may have access to our own internal resources. Self-hosted, you could put it anywhere. It could be inside of your Azure VNet. It might be on an on-prem server somewhere. Right? And accepting arbitrary code to be running in those environments is far more dangerous. It's a much higher security risk. So organizations really want to take a look at restricting what repositories are allowed to use those self-hosted runners. Those have to be repositories that we implicitly trust and which teams are likely to run on them. So this is internal, and we will see external. So where you go in here, we go into the organization settings, actions runners. We can specify a runner group, more on that in a moment. And then at that runner group, we can determine should these repositories be able to use it, or we could set either like just no public. Right? No public is the lowest bar, right? That really aren't very comfortable running code that's in a public repository on those self-hosted runners, because again, contributions can come from the outside world. Going a little bit further, where are we going to be putting our reusable components? Back in the earlier section, in Module 3, we talked about kind of some of this reusability aspect. In that reusability aspect, we built these components, but where are they going to reside? Where are they going to live? And we talked about like in the current repository, which isn't incredibly shareable, or outside of that. And so here we're looking a little bit deeper into that. So our reusable workflows, we may have in our organization, we may have a repository where we're building some of those reusable workflows, maybe where we're setting up some best practices that could be at the organization level. But we could also say that maybe we have a team whose goal is to provide best practices throughout the org and create a designated organization that holds those reusable workflows, those custom actions, those shared scripts. So here we want to kind of take a look at where is that sharing being done. Do you want to share within the org, or do we want to go a little bit broader than that and have maybe certain organizations where we have repos in there where our reusability takes place? Now, we briefly talked about runners earlier. We're going to delve a little bit more deeply into how these runners are set up and how they're managed at the organization and the enterprise level. These are really important infrastructure decisions that you are making when you're setting up these individual runners. And so a couple things to keep in mind. Our decision between GitHub runners and self-hosted runners is an important one. GitHub hosted being safer for us to execute code, self-hosted typically having more access to more resources. So in here, we're going to see some of the differences and comparisons that we want to be aware of with our GitHub hosted and self-hosted runners. So GitHub host, the first thing that we're seeing right here is that in GitHub hosted, they just get updates. We are not responsible for maintaining the updates or the infrastructure of GitHub hosted. So we know we're getting the latest versions available without us having to do a lot of work. So GitHub does maintain and manage those. We also know that every time we run these, we are going to be running on a new, clean, independent execution. This is often desirable, right? We really like things that are ephemeral, that are transient, that we can expect the same environment every single time. That just happens automatically when we're looking at the GitHub hosted environment. Now, the downside here is that they do cost minutes, right? So there's an allocation of free minutes, and then there's going to be a fee for additional minutes on top of that. So they can, especially if we're running lots and lots of workflows, that can stack. On the self-hosted side, we're responsible for getting the infrastructure updated. The runner application, the little agent that you install, that can get automatic updates. But the underlying infrastructure, the operating system that's on there, the frameworks and things that you've installed on there, you're going to be responsible for maintaining those. We do have flexibility in where they go. We can talk to cloud services if we're deploying to something like Azure. We could talk to on-prem. The visibility increases every time. But then you're also responsible. It is possible for a workflow to make modifications to its environment, depending upon what you've allocated, which means one workflow could potentially influence another one. So we want to make sure that we're a little bit more diligent about cleaning up after ourselves when we are running on a self-hosted. But they are, free to use within GitHub Actions. There, because you're responsible now. You're paying for those machines upon which it is running. Then we have to look at when a workflow is running, it has the ability to potentially reach out. In earlier examples, we said that we could call into a REST API. Do you necessarily want an action to be running and to reach out to the outside world? Right? It's often something that we need to be able to control. So when we are looking at our self-hosted runners, we can supply an IP allow list. We can say these are the IP addresses or ranges of IP addresses that we are going to allow our runner to reach out and talk to. So the admin who's putting this together is going to be responsible for maintaining those. So you'll need to know what VPNs or cloud security groups are appropriate and keep those up to date and keep those constrained when we're looking at self-hosted runners. This is also then the big scary slide about what could go wrong when you are running things on self-hosted runners. And we've got big print here to kind of to illustrate the scariness that's going on inside. So there is possibilities, depending upon who has access to the repository in which the workflow resides, it is possible for remote code execution, RCE, by malicious actors who have contributed. There have been a number of cases where folks have accepted contributions that seemed to be innocuous, that had troublesome payloads. Continuing with remote execution, going a little bit further, it is possible that if that is set up the right way, that we could have things like cryptocurrency mining or resource exploitation using your hardware without your knowledge. We also talked about the IP restrictions, right? We want to be able to restrict so that data isn't sent outside of your environment, whether that data be like the data in your databases or the files on your system, or be things like credentials, right? The secrets that are available inside of your resource they are available inside of your workflow, which means they're available to the malicious actors who may have gotten code in there. It's also possible to enable things like denial of service attacks and lateral movement within your infrastructure. They are on a self-hosted machine in your infrastructure. It is possible for them to that be the starting point to find out the rest of your environment. So what do we do? Right? How do we lock that down? We've got a number of options here. Right? Restrict self-hosted runners so that they're only available to our private repositories, public repositories, no dice. That reduces the surface of where malicious actors can contribute. Right? Require workflow approval. Right? So if we do have them on servers where we're getting external commits, then that doesn't happen automatically. They do not run automatically. It requires someone to approve. Then we have to have a training aspect to that approver. And we have to say, you need to really take a look at what we are accepting in. Right? Make sure that the runners themselves are not just in the public space. Most of your, if not all of your runners should be isolated, especially if they don't need to be touching things like production. They shouldn't have access to production. You want to keep their scope, their visibility as small as necessary. Set up appropriate firewalls and network rules so that they can only reach to the things that they are supposed to have access to. Reduce the number of secrets that they have available to us, to them, and keep an eye on what they're doing. This is just standard activities we need to be able to monitor and to log what's going on in those runners. Now, you can do this at kind of an individual runner basis. At some point in time, you will have enough runners that becomes very cumbersome. So we also have the idea of runner groups, which allows us to apply policies and strategies at multiple runners simultaneously, as opposed to one at a time. So depending upon your organization enterprise level, you can see here if we're using the free plan or the pro plan, we don't have groups. You're just your individual runners at that point. But at team and enterprise level, you do have the ability to take a group and then cluster together certain runners and say, okay, this particular group is running on-prem in resource A, therefore we will have one set of policies over the top of it. A couple of ways to then look at what's going on at a runner level. There is an API that we can use where we can call out to a runner to check its status. Right? Are you online? Are you offline? And to get the logs from that particular server so that we can see how it's been running. So part of your monitoring strategy needs to be observing those runners. And our last piece in all of this is taking a look at secrets. So when we last talked about secrets, they were at, in essence, the repository level. We were looking at, we could set secrets up at the environment inside of a repository or at the repo level. But we also have to then start branching to org and to enterprise as well. So we have now new scopes that we hadn't talked about before. So this is what we have seen, that we can set those up at the environment. Remember, a single workflow can have multiple environments that it's flowing through. Those can have their own individual secrets. We can have secrets that are repo level wide. But we can also start moving up. You can imagine that inside of an organization, you are likely to have a number of common resources. So, for example, database servers. And the fewer number of places we are writing down, like the credentials, to talk to those servers, the better. And so it may make more sense to have secrets at the organization level that are used at the organization level and then allow certain repositories access to those secrets. And then going up one more level, we can also do this at the enterprise level. So Enterprise Cloud does allow these enterprise-wide secrets. So the enterprise secrets, again, only available here at Enterprise Cloud. When we're looking at organization secrets, we do have the ability to say only certain repositories. We want the principle of least privilege to be used instead of making it available to everyone. Only the repos that absolutely need it, add that to the list. And environment level secrets, smallest level of scope that's available to us, so they're not exposed further than they need to be. When we're looking at secrets and their exposure, many of you may be aware that we have lots of tools available to us beyond just GitHub for secrets. And in many cases, they are preferred. So we're looking at HashiCorp Vault, we're looking at Azure Key Vault as options external to GitHub. These are often the preferred approach. Instead of storing secrets at the repository, at the organization, at the enterprise level, we store those closer to the resources that are actually going to need them. Now, this can't happen for everything. For example, we have to get there at some point in time, so there may be some resources that have to be stored inside of our secrets. But when it comes to our applications that we are deploying and the secrets that they need, we often don't want those in the workflow. We often don't want the DevOps folks to necessarily need those. If we have a SQL password, let that be known by our SQL admin and have them put that inside of, say, Key Vault. And then from there, we can either pull during the workflow if we need it, or we can let the applications handle it on their own. There's a number of benefits to having these third-party vaults. So keeping them much more centralized instead of spreading them out from resource into pipeline. Many of those tools will have automatic secret rotation capabilities where we don't have that inside of GitHub. Having a single source of those secrets means that we have one place to look to see who got access to them. The more we spread that out, the more we have to look for all of those. And we do have, if they're in one location, we can keep the access to those at a bare minimum. So while we've got a lot of secrets capabilities inside of GitHub, inside of those resources, do keep a firm eye on the external tools and use those when appropriate. All right, folks, before we finish up for the course, I just want to do a little bit of a dive into the idea of secrets. And so I have a repository here where we can do a little bit of with. So I'm going to dig into our GitHub folder and our workflows. And we have a very specific workflow here called use secrets. And use secrets just expects me to pass in a key here, your secret, and then some form of secret should go here. Now, we could just paste in, a secret, right? This is the token that it expects to use, and this is just a disastrously bad idea. Not only is it sitting in clear text right now in a public repository, so super easy to steal, it is deeper than that because it's also in the history of this repository. So even if I were to delete it out of the current branch, it's still in that history. So we would have to go through a purging process to get rid of it. So I'm not going to do this. It just feels a little bit too bad. But we will go throw it into our secrets collection. Now, where I'm going to go right now is the settings of the current repository. So I swing into those settings. It's okay to leave. And into those settings, we have secrets and variables, specifically here for actions. Now, here we've got two sections. We do have the repository secrets, and then we have a link to environment secrets. This is really going to jump us off to the environments section. over here where we would get them. So it's just a quick little shortcut. But our particular workflow right now isn't using environments. So while I like them there, if I were to put it there into an environment, it wouldn't pick up on it without modifications to the workflow. So I'm going to drop it here into my repository secret. I'm going to create a new secret in here. We will call this repo secret, and we will drop in said secret. Now, by the time you watch this, that secret will have been destroyed. So, have fun with it, I suppose. But yeah, that will be destroyed in mere moments from now. But I will add that secret. It is now in the collection at the repository level, and we will swing into our workflow, and into the workflow, we will edit this file. And it's expecting a key called your secret, and then we pass in its location. So we will do a $, double curly, secrets dot, and we called it repo secret. So that should, we'll commit that change. You'll see here that we have, in terms of a trigger, on push to this particular file alone. So any changes to this will rerun this file. So our action should take off. There's a little grading there to see that it's coming from our repository and not just pasted in the secret itself. So in theory, momentarily here, we should see a nice little pass right here. And indeed, we did pass. We've got our little grading system that says that we did the right thing. So life is good. So it found it in the repository. Now, we'll go back to the settings here. Let's go and delete that one. Go into our actions here, and we will delete it at the repository level, and we will move up to the organization level. We'll stop here at the org, but if we were in an enterprise edition, we could move up again one more level. But I'm going into the settings for the organization as a whole. It also has a secrets and variables section, nice and consistent. It also has an actions section here. And we will create a new org secret. So here we will call this, appropriately enough, org secret. We will paste in that same value. And you'll see here we have a little bit different option when it comes to like saying who has access to this. So maybe only the private repositories, only the repositories that are inside of my organization that are private. That's a strong setting. I could go and say any repository, or I can go and say selected repositories. So I'm going to go and do that here. I'm going to grab selected repositories. We will pick which repository, and specifically we will grab the use secret. We do get a flag here that it indicates which of these are public and which are the private. Right now they're all public. But I'll update that selection, and I will add the secret. What we're hoping for is when we swing back to our repositories, specifically into use secrets, we'll make one more edit, and we should get success on this as well. Swing into the workflow, into use secrets, do a quick little edit here, and instead of using the repo secret, which we now know is gone. If I were to run this, we would break it. But we'll just switch that to an org level secret. We'll go ahead and commit those changes. And when we swing into the actions here, we can see the grading came back and said, hey, you did it. So it found it at either level. So it is not
at the code level here, we don't have to specify where that secret is found. We just have to know the name of said secret. And you will often do some form of namespacing right here, maybe the org underscore or whatever, to kind of build out maybe a hierarchy of these secrets, because a little bit of a too flat of a system, it makes it a little bit difficult. So there you have it. Just a quick rundown on the levels where you're going to find those secrets. And now let's wrap this up.
My friends, we've looked at a lot. In this last section, we looked at enterprise and organizational level policies that help us control what can be done with our workflows, with our actions, with the runners that they're going to be executing on, and with who's in charge of our secrets. We've just started on this venture into GitHub Actions, but I hope this has been a valuable start for all of you learning GitHub Actions. I can't thank you enough for taking the time to spend with me in GH-200 automating workflow with GitHub Actions. We have touched a lot of components. We started with just what are workflows, what are actions, what are the components that make that up. We got into the components that support our pipelines, both our continuous integration and continuous delivery components. We saw what it takes to start reusing those, whether we're building our own templates or whether we're starting to create our own individual actions. And then we took a look, we just finished up, with looking at the configurations that could be set at the organization level or the enterprise level. And like I mentioned before, this is really just the start. There's a lot more involved, and you really want to get your hands on all of this. If you take a look at the Microsoft Learn content, you will see all we've been talking about and more. In there will be a series of hands-on labs, 1 to 3 labs per section that we talked about will be available. And again, as we mentioned kind of at the very beginning of this, I would highly encourage you to look at those labs, if not from the lab itself is interesting, to the lab infrastructure, because these do exist on GitHub and are implemented by GitHub Actions. So this particular module, this particular course alone, those are really interesting. Let this not be the end. There are many things that you're going to want to do going forward. So for example, there is a GH-100 course that talks about a little bit of the product features that you may or may not have seen all of, but then what does it look like to be an admin on GitHub? Or you could take a look at GH-500. This is a really important course, especially for those of you who are putting together actions, because we looked at what does the workflow look like and where can we put individual actions, but we really didn't look at, well, what are those actions that are going to protect you from malicious code that's been injected? What are we going to do to protect ourselves against a bad dependency that might be a license violation or might be a security risk? Well, we've got tools inside of GitHub that are easily invoked from our actions that you do take a look at in the GH-500 Advanced Security class. I just want to thank you all for taking the time to watch all of these videos and for having kind of an understanding of the engine that drives all of this. I'm Rob Folkrod, and I hope you've enjoyed the course.